Hi, Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present our study about house price of unit area. So, this is our group member which is Nur Sahira binti Mokhtar, Muhammad Amirul bin Azlam, Muhammad Syahmi Afiq bin Ahmad Sanip, Nurul Rabiatul Adawiyah binti Jawahir, and lastly, Siti Nursyaqila binti Mohamed Yusof.
Nowadays, people are struggling to own a house. House is most essential asset for any individual or family, especially to the man who needs to own a house before he create a family. Meanwhile, they are willing to rent a house rather than buy itself. The house price keep increasing years by years due to many factors. And there is also a large gap of house price if we compare to the years before. So, the main purpose of this study is we want to determine the factor that influence the house price. The main area of factor influencing the house price are house age, distance to the nearest MRT station, and the number of convenience stores.
Next, we proceed to our study's theoretical framework. As you can see, we choose three independent variables for our study, which is house age, distance to the nearest MRT station, and number of convenience stores. And for our dependent variable, house price of unit area is selected.
There are three research objectives for this study. The first objective is to determine the significant relationship between the house age and the house price of the unit area. Secondly, is to identify the influence of the distance to the nearest MRT station on the house price of the unit area. The last objective is to determine the significant relationship between the number of convenience stores and the house price of the unit area.
Nowadays, we can see that there are a lot of houses distributed by the developer in street, especially in the rural area. Most of the houses are not owned and abandoned till they are dilapidated. We as the researcher are wondering and curious about why this thing happen. Because if we compare the house in town and the house in the rural area, we can see that the price of the house in town are more expensive than in the rural area. In addition, there are many facilities that are provided near the house in town, which cause the people to buy it.
Next, the significance and limitation for the study. First, for the significance of the study, we construct this study to help people who plan to buy a house. As we all know, value of houses have fluctuated significantly in the last decades. This sort of indecision creates an obvious effect on the people who wish to invest or buy housing. Next, demand for housing is dependent upon income. With higher economic growth and rising incomes, people will be able to spend more on houses. This will increase demand and push up price. Next, for limitation for the study, first, data gain might be biased. The second one, the data is not accurate. And the last one, the past researchers did not state what variable they used in the project. Next, we continue to analysis part A. For the descriptive analysis, this is our table of variables. The total respondents in this dataset is 415 respondents, but the number of observation used is only 414 because there is one missing value in this data. We conducted several quantitative variables such as house age, distance of the nearest MRT station, number of convenience store, and house price of unit area. The mean and standard deviation for house age is 17.7, 126, and 14.3925. The mean and the standard deviation for distance to the nearest MRT station is 1083.89 and 1262.11. Then, and the mean and standard deviation for the number of convenience stores is 4.0942 and 2.9456. Lastly, the mean and standard deviation for the house price of unit area, which is our Y, is 37.9802 and 13.6064. Next, we proceed to our demographic analysis. This is the bar chart for the frequency of house age. As we all know, the surrounding and the environment of the new house are more interesting than old housing. So, the house price will increase. The highest house age is 14 years with 18.84% and follows after 18 years with 17.39%. Lastly, for 30 years and above, it is 8.45%, 10.14%, 4.83% and 1.93%. The second one is a histogram of the distribution of distance to nearest MRT station. The graph shows that it is skewed to the right because the percentage rate of the right side in this graph gets lower as the distance to the nearest MRT station increase. This is the bar chart for the frequency of the number of convenience stores. Something being located within a reasonable distance to a grocery store save nearby home owners' time and money that would otherwise be spent on petrol and traveling to grocery further away. The highest frequency of the number of convenience stores is 0 and 5 stores. For 16.18%, next, follow after 1 and 3 stars with 11.11% and 6 star with 8.94%. Lastly, the lowest frequency of the number of convenience stores is 10 stars with 2.42%.
Next, from the coefficient table, all the independent variables are significant since the p-value are less than alpha, which is 0.025, and our full linear regression equation is y hat equal to 42.0772 minus 0.252x6 x1 minus 0.00538 x2 plus 1.29744 x3. From the ANOVA table, the p-value of the model is 0.0001 is less than our alpha, which is 0.05. Hence, we can conclude that the model is significant and the data can be used to the study. Besides that, for the model summary, there is 54.11% total variation in the house price of unit area can be explained by all the independent variables. The balance for 45.89% of total variation is explained by other factors. The standard error is quite large value with 9.25136.
For the model adequacy checking, the first assumption is linearity. Based on the scatter plot matrix, the figure shows a non-linear relationship between house price of unit area and house age. There is also non-linear relationship between house price of unit area and distance to the nearest MRT stations. For the normality of the error term, the QQ plot of the residuals show that the error term is not normally distributed because not all point lies on a 45-degree line. Next, for homoscedasticity, the graph of the residual against the predicted value shows the error term is not constantly lying between -40 and 40. The error variance is not constant. The next assumption is the independence of the error term. By looking at the Darwin-Watson, the error term is independent since the Darwin-Watson value 2.115 is between 1.5 and 2.5. For multicollinearity, the correlation of estimates show no multicollinearity problem since there are no pairs of predicted variables that are more than 0.8. We can also check the presence of multicollinearity by looking at the tolerance statistic and the variance inflation. By looking at the table, the values of the tolerance statistic and variance inflation are greater than 0.2 and less than 10 respectively. Hence, there is no multicollinearity problem. For the last assumption, outlier, the graph of the residual against leverage shows the presence of outlier as 24 leverage points exist in the outlying case with regards to the value. The 24 leverage points are the 9th, 49th, 50th, 59th, 91st, 100th, 117th, 124th, 147th, 171st, 177th, 182nd, 233rd, 250th, 256th, 302nd, 304th, 305th, 310th, 332nd, 341st, 346th, 348 and 387 observations. The Cook's distance diagram also shows that 24 observations are influential cases. The influential cases are the 9, 16, 17, 48, 106, 114, 117, 127, 129, 149, 165, 167, 221st, 229, 250, 256, 271st, 331st, 313, 345th, 362nd, 380th, 387, and 390 observations.
For analysis part B, we do some transformation to the model to make the model become more significant and fulfill all the assumptions of regression model. For step 1, we remove any variable that are not significant, but since the p-value for all variables are under 0.05, there are no need to remove any variable. For step 2, we transform the independent variable. Except for x3, we transform the x1 into ln x1 and we transform the x2 using the natural log. For the next step, we transform our dependent variable y also using the natural log to fulfill the assumption of normality of the model. And for the last step, we remove the outliers. We remove the outlier by checking the Cook's-D chart, and we found out that there are a total of 6 observations that need to be removed, which is 114, 149, 271, 274, 276, and the last one is 403. We check the Cook's-D chart by using the rule of thumb as shown in the slide.
The previous model, we have identified the presence of outlier and we modify our data set. The transformation have been conducted by transforming y into log 10y, x2 into log x2, and x3 into log 10 x3. It is because both independent variables are not linear with dependent variable. From the coefficient table, we conclude that all the independent variables are significant as their p-value is below than alpha, which is 0.05, and our equation final model is log 10y equal to 2.18457 minus 0.02934 log x1 minus 0.21743 log 10 x2 plus 0.01063 x3. Besides that, for the model summary, there is 67.08% total variation in the house price of unit area can be explained by all the independent variables. The balance for 32.92% of total variation is explained by other factors. The standard error is 0.09478, which is good because it's smaller than the previous model.
After transformation has been made, we must recheck the model adequacy checking to fulfill all the assumptions of the regression model. So, the first assumption is linearity. Based on the scatter plot matrix, there is linearity between house price of unit area, which is log 10y, and distance to the nearest MRT stations, which is log 10x2. For log x1, the transformation shows that there is approximately linear between house price of unit area and house age. For normality of the error terms, most of the points lie on the 45-degree line on the QQ plot of residuals for log 10y. We can describe that the errors are normally distributed. Next is homoscedasticity. The residual against predicted value graph shows that the error terms are in the range between negative 0.2 until 0.2. Most of the points are distributed. It can be proven that the error variances are constant. We proceed to the independence of error term. The error term is independent since the Durbin-Watson is 1.923 and the value is in the range of 1.5 and 2.5. After transformation has been made, there is still no multicollinearity since there are no pairs of predicted variables that are more than 0.8. The values of the tolerance statistic and variance inflation are greater than 0.2 and less than 10 respectively. Hence, there is no multicollinearity problem exists.
From this study, we conclude that we can fulfill our assumption of regression model by making a transformation. Our original model has already significance, but there are some assumptions that are not fulfilled. From this study, we transform our x1 into log x1 and x2 into log x2 to fulfill the assumption of linearity of the model. Also, we transform our dependent variable y into log y to fulfill the assumption of normality of the model. After transformation has been made, we can conclude that our model has become more significant and all assumptions are fulfilled. Last, by checking the significance of the model, we can make the best model of it and achieve our objective of the model. Thank you.